So ladies and gentlemen, you are all welcome to my YouTube channel. So today we are going to look at the concept of electrolysis. So what is electrolysis? From the word lysis. From the word lysis means breaking down. So electrolysis, the lysis means breaking down. Then electrolysis, for electro means electric current. Electric current. So electrolysis means is the breaking down of substances using an electric current. So what are the substances do we actually break down in electrolysis? Is electrolytes. What is an electrolyte? Electrolytes are compounds that are dissociated or break down during electrolysis. And usually electrolytes are ionic compounds. They are ionic compounds. So electrolytes are compounds that decompose or are chemical substances that decompose during electrolysis. And of course, these electrolytes are divided into two. We have what we call weak electrolytes. Then we have what we call strong electrolytes. So when we say weak electrolytes, the word weak electrolyte means substances that break down partially. They are partially break down. So they are partially dissociates. Like for example of this weak electrolytes, when we have CH3, COOH. So during an electrolysis, when you apply an electric current, electric current stands for I. So I stand for electric current. So when you use an electrolyte, when you use an electric current, in the case of weak electrolyte, it is just partially dissociates. Like for example, in this case, when you dissociate, this is ethanoic acids. So when you use an electrolyte, it will just partially break down to produce free hydrogen like this. So, and of course, in the situation where we have strong electrolyte are electrolyte that completely dissociates, or that completely ionize, while weak electrolytes, they are partially ionized. So, and we also have non-electrolytes. We also have non-electrolytes. When we say non-electrolyte, it means that they are not dissociated at all. They are not dissociated. So now we are talking about electrolysis. So we said that electrolysis is a chemical decomposition of compounds. It's a chemical decomposition of compounds into their component ions by passing an electric current, either in a solution or in a molecule form. So the first thing that will come into our mind when we say electrolysis, it means breaking down of compound into their component ions by passing an electric current, either in a solution or in a molecule form. For example, now let's say we have sodium hydroxide. So in electrolysis, this sodium, or let me just say sodium chloride. So this sodium chloride use electric current, using an electric current, it will decompose. It means that it will break down to produce sodium ions plus chloride ion. So what is the sodium ion? So a sodium ion, it has a positive charge. So any element that have positive charge after dissociation is called cations. It's called cations. While those ions that produce negative charge called anions. They are called anions. So there are some important terms. There are some important terms that we should know when we are talking about electrolysis. We have what we call electrodes. Electrodes. What is electrodes? Electrodes is when we say that electrodes is actually it can either be anode or cathodes, where an electron leave or enter electrolytes. So we have two types of electrodes. We have anodes. Anodes are positive charge. Anode are positive charge electrode. And then we have cathode. Cathode are negative charge electrode. So generally anodes have deficiency of electron. They are deficient in electron. Deficient in electrons. It means that they have, when we say they are deficient in electrons, it means that their electrons or their number of electrons is very low. So they need electrons. It's like they are hungry of electrons. That is anodes. Then we have cathodes, which are negative charge, and they are sufficient in electrons. They are sufficient in electrons. So it means that when you say that they are sufficient in electrons, it means that they have excess electrons. They have a lot of electrons. They are rich in electrons. While anodes, they are deficient in electrons. They are deficient in electrons. So now, as we said, we have cations and anions. So cations, in some other case, we call them cathode ions. Why is that they are called cathode ions? You see here in this case, sodium is having positive charge. Sodium is having positive charge, meaning that it is not, it is actually, for it to become a neutral, it needs an electrons. So in this case, sodium ions, it is also deficient in electrons. So it needs to become stable. It needs to become stable. So what will happen? These sodium ions, that is why they are called cathode ions. So they will migrate. They will migrate to cathodes. Because in the cathodes, there are sufficient electrons. So therefore, in the cathode, sodium, in the cathode or at the cathode, sodium ion would now accept electron to become neutral sodium. And of course, anions, they are called anode ions. Anode ions. And they have excess electrons. They have excess electrons. And of course, in the anodes, they are deficient in electrons. They are hungry of electrons. And this chloride ion, it is highly rich in electrons. So therefore, what will happen? Then the chlorine at the anode, chlorine will migrate to the anode, and then it will now loses its electron to become chlorine. but chlorine always is coming, or chlorine always coming in the form of fluorine is always coming in the form of diatomic gas. So it has two electrons, so two electrons here. We now have fluorine gas. Therefore, chlorine always exists as diatomic gas. So therefore, two molecules of chlorine will now loses its two electrons at the anode to become molecular, or to become chlorine molecule. So this is what actually happens during electrolysis. But one thing that we should understand in electrolysis is that generally when the chemical compound break down, so actually produce an ions, and that ions will move in random direction without knowing any direction, or without, like for example, generally, like for example, if you take sodium chloride, which is a salt, and you now put it inside water, it will break down to produce sodium ion and chlorine ion. But the sodium ion and chlorine ion will move randomly. After the ionization, they will move randomly. They will move in random direction. So what happened? They will continue moving in random direction without knowing anywhere they are going to actually move or migrate until an electricity is applied. That is where you will have the two electrodes, the cathodes and the anode. Then the cathode will now migrate towards, the cations will migrate toward the cathode, and the anions will migrate toward the anode. So now let's look at the structure of electrolytic cell. So you see now, during this electrolysis, we have, this is the anode, and this is the cathode. So, and of course, this is our electrolyte solution. And then we have, in our electrolyte solution, we have sodium ion, we have chloride ion. So sodium ion, that is those that have positive charge, they are called cations. And then the chloride ion, because they have negative charge and they are called anions. So during the course of electrolysis, as I said, the positive charge ions, which is the cations, let's look at exactly what happened at the cathode. So at the cathode, we have sodium ion. So sodium ion, because cathode, they are negative charge. So sodium, they are called cations, and they are called cations because they are dot ions. So these sodium ions will migrate toward the cathodes, and of course, at the cathodes, this sodium ion, because of course cathode, they have excess electrons, so they have sufficient electrons. So therefore, at this stage, the sodium ion will now gain electrons, now accept electrons from the cathode. So therefore, sodium ion will now accept electrons to become sodium metal. So at this stage, we have sodium metal. So at this stage, what happens? It means that sodium gain an electron. And of course, remember from the basic knowledge of chemical reaction, whenever we have oxidation, so whenever we have a gain of electrons, or when there is a gain of electron, then we have reduction. So it means that reduction takes place at the cathode because there is a gain of electrons. And then the anode, so in the anode, there are positive charge, so they have excess electrons. So at this stage, the sodium ion, the chloride ion, that is the one with the negative charge. At that point, actually, it is going to going to lose these electrons. So we're going to lose electron to become chlorine. So of course, two molecular chlorine, because chlorine always exists as a diatomic gas. So chlorine will lose two of its electron to become molecular chlorine. So because at the anode there is a loss of electrons, so chloride ion loses its electrons, so it gives anode to its electrons, so it loses electrons, and that is why oxidation take place at the anode. So oxidation takes place at the anode. Just as I said, oxidation is the loss of electrons. It's the loss of electrons, and the reduction is the gain. It's a gain of electrons. So sodium gain electrons here, and chlorine ion uses electrons, and that is why we have oxidation at the anode and then reduction at the cathodes. So that is what happens. Electrolysis, all these ions will migrate toward the positive charge will migrate toward the cathode, and then the negative charge will migrate toward the anode. So now the next thing that we are going to look at is actually the factors that affect the differential discharge of ions during electrolysis. Like for example, what are we seeing now? Let's see. Of course, during electrolysis, like for example, let's see you have sodium ion, or we have sodium chloride dissociate to produce sodium ion plus fluoride ion. So maybe this sodium ion is actually also is dissociated in water. So the water itself also dissociates to produce hydrogen ion and of course the hydroxyl ion. So now we have these two ions. We have two cations and we have two anions. But we don't know actually because of this which one will migrate toward the cathode. So which one will be discharged and which one is not going to be discharged. So there are the factors that affect the differential discharge of ions during electrolysis. And these factors include number one, position of ions in the electrochemical series. In the electrochemical series. And then number two, concentration of ions. Concentration of ions. And then number three is the nature of electrons. So these are the factors that affect the differential or that affect the discharge of ions during chemical series. We have chemical series, we have concentration of ions, and then we have nature of electron. So actually we have what we call electrochemical series. So generally elements that are higher in the electrochemical series will discharge those that are lower in the electrochemical series. Because like for example in the electrochemical series, for example we can have a situation where we have like for example we have sodium, potassium, aluminum, and others. So generally sodium, potassium, sodium, magnesium, they are higher in the electrochemical series. So now let's say, and of course we have hydrogen ion. So now look at it, in these points we have sodium ion and we have hydrogen ion. So between this and this, which one is higher in the electrochemical series? Hydrogen ion is lower in the electrochemical series, while sodium ions, it is higher in the electrochemical. So therefore, in the case of metal ions, those positive charges, those that are higher in the electrochemical series, of course, will actually discharge those that are lower in the electrochemical series. But in the case of negative charge, that is non-metal, those that are lower in the electrochemical series will displace those that are upper in the electrochemical series. And there is also concentration of ions. Like for example, now let me just give an example. We have sodium ion and we have hydrogen ion. So between sodium ion and hydrogen ion, which one is higher in the series? Sodium ion is topper in the series, so therefore it will now displace sodium ion. And then the next thing is also in the case of the chloride ion, hydroxyl ion. So therefore in the case of fluoride ion, sodium ion, Sodium ion is topper, and of course hydroxide ion is lower in the series. So in the case of negative ions, that is non-metal, those that are lower in the series will displace those that are topper in the series. So therefore now what we are seeing here is that based on the position of ion in chemical series, we are now going to see at the anode, or let's say at the anode, because at the anode it lies, they have positive charge, so we expect chlorine and hydroxyl ion to migrate. But because OH is lower in the series, so it will displace chloride ion in the series. So therefore, it's the OH minus that will be migrated to the anode, and then it will now form a gas. It will form a gas. So usually it's 4 molecules for the equation to be balanced. It's usually 4 molecules of OH minus. So therefore, at the end, we are going to have 2 molecules of water plus molecular oxygen. So it means that molecular oxygen will be produced at the anodes based on the position of ions in the electrochemical series. Then we also have hydrogen ion and chloride ion. So because in terms of the metal, sodium is topper in the series than the hydrogen ion. So therefore, the sodium ion will displace hydrogen ion. So therefore, at the anode, at the cathode, in the case of sodium ion and hydrogen ion, at the cathode, sodium ion will be migrated. So we have sodium ion which will actually accept 1 electrons to become a neutral sodium. So this is actually what happened at the cathode and at the anode. So there is also a concentration. There is an issue of concentration of ions. So now, usually, like for example, here we said we have chloride ion and we have OH minus. So which one displaces? OH minus displaces chloride ion. But in terms of concentration, if in the situation where OH minus have higher concentration than the chloride ion, it means that, if in a situation where the chloride ion concentration is greater than the concentration of OH minus, then the chloride ion will now displace the OH minus. And also in the case of situation where we have, but if the concentration, like for example in this case, if the concentration of chloride ion and OH minus are the same, so of course the position of ions in the electrochemical series must play a role. And of course, in the situation where the concentration of OH is greater than that of chloride ion, then of course the OH minus will go because the concentration is higher and it is also lower in the series in terms of the non-metal, so therefore it will displace chloride. But in the case where the concentration of chloride ion is greater than the concentration of OH minus, then of course the chloride ion will now displace OH minus. So concentration also plays a role. And also in the situation where we have sodium ion and hydrogen ion, because if the concentration of hydrogen ion is far greater than that of the sodium ion, then of course the sodium ion will be displaced. So therefore hydrogen ion will be migrated to the, of course, cathodes. So, and of course we also have the nature of electrodes also the last one, which is the nature of electrode. An electrode also affects the preferential discharge of ions during electrochemical series. Like for example, if you use nitrogen electrodes, it also affects that. So ladies and gentlemen, the next thing that we are going to look at after this introduction is actually Faraday's law of electrolysis. So we are going to look at the Faraday's law of electrolysis. So under Faraday's law of electrolysis, we have two laws. And of course the first law of electrolysis states that during electrolysis, generally the mass of an element that undergoes electrolysis is actually deposited. So and of course that mass of an element, like for example when we have sodium chloride deposited during an electrolysis, so of course going to be sodium ion plus chloride ion. So during this electrolysis, of course, the mass of an element are usually deposited. So, but the mass of the element that is deposited during this electrolysis depends on the quantity of electrical charge that is applied. So it means that the mass of the elements during electrolysis is directly proportional to the quantity of electricity applied. So of course, this proportionality, of course, whenever we have proportionality, we introduce constant. That is why we have M is equal to Z. So Z here is constant, which is called electrochemical equivalence. Electrochemical equivalence. We call electrochemical equivalence. So during electrolysis, the mass of an element discharge during that electrolysis directly proportional to the quantity of electricity that is applied. And of course, we know that Q, when we say quantity of electricity, is stands for Q, which is equal to IT. The I stands for the current. The I stands for current, which measures in ampere, and then we have T, which is time, and it is measured in second. So the mass of an element that is discharged during electrolysis is dependent on this quantity of electricity. So of course, we are now going to look at some questions. We are going to look at some questions and we'll solve them in the next video. So therefore, the next thing that we are going to look at is actually Faraday's second law of electrolysis. So this is Faraday's first law. This is Faraday's first law of electrolysis. So this is the Faraday's first law of electrolysis. So the next thing is actually the second law. Is Faraday's second law of electrolysis. The Faraday's second law of electrolysis. So under the second law of electrolysis, or the Faraday's second law of electrolysis, said that the mass of an element deposited during an electrolysis is directly proportional to their respective chemical equivalent. You can have a situation where you can have more than one electrolyte in an electric circuit. So when you apply the same quantity of electricity, so the mass of the element deposited during the electrolysis is directly proportional. The mass of the element deposited during this electrolysis is directly proportional to their respective electrochemical equivalent. So of course here we have the mass which is represented as W. So we are now going to have W is equal to of course K Z. So at the end we have K as constant. We are now going to have W over Z is equal to K. So we are now going to have W 1 over Z1 is equal to W 1 over Z2. Which is, of course, we can make it subject of the formula, so it can be W1 all over W2 is equal to Z1 all over, it's equal to Z1 on Z2. So this is the formula that we are going to use in solving second law of electrolysis. So ladies and gentlemen, we are going to now have another video. Actually, in that video, we are going to solve various questions or problems that are associated with electrolysis. Thank you.